walk you guys through the concept that we have for the 5000ES and transformer. As you know, Signature Solar was the first Growatt distributor to bring in the 5000ES. We worked directly with Growatt on bringing in the American version of this unit. And I think that the traffic that we gained kind of drove a lot of other people in that space to try to bring in the 5000ES, and they didn't bother getting the American model. But I want to walk through sort of the things that have been done to make sure that people that have bought from us have been safe, and also just a general walkthrough of the actual strategy and how the math works. Because the 5000ES really looks good to people building larger off-grid systems, and the whole conversation around removing screws, that's like a band-aid that people who bought the wrong model are telling their customers to do, and it's really unsafe. Because one of the things about the boards that we get, this is the screw they're always trying to remove, right here, okay? And I've seen guys say, well, we removed that, and then they've said, well, there's still a contact line. Well, this is the thing about buying the right unit. When you buy the right unit from a manufacturer, they send you the right board. Right there, there is no metal contact there. That is a piece of silicon. So there's no grounding. There's no leakage between ground to neutral. You truly get an unbonded unit. I'll be honest with you, the bonded unit works in Europe, but frankly, you don't want this neutral ground bond in the United States. You're only supposed to have one neutral ground bond on your entire system, according to the NEC. So the way the U.S. does electrical bonding and grounding, it doesn't even make sense to have a bond. But with our boards, we actually bought the right unit. So there is no screw, and on the back side, there is no contactor. I get it, there's a lot of people trying to clean up after not buying the right units. That's not something that we could control. And we don't tend to like to go after other people on that, but this is just something that I think the whole conversation that people are having sort of revolves around these external buyers. But I think that what's mostly misunderstood is the transformer and what watts actually touch it in a system that's mixed 240/120 split phase. So if we come up here on the board, we've got 240 volts going line 1 to line 2, and then the transformer, if that's tied into the same breaker panel, creates that midpoint, and that's where your neutral's coming from. And from neutral to line 1, you have 120, and neutral to line 2, you have 120. Now, that's all fine, but let's walk through a few facts here. If you have 240 volt loads, let's say we have a scenario where we're going to put 5 kW of 240 volt loads. That won't even touch the transformer. It's going to go directly from the line 1 and line 2 terminals of the inverter and feed that 240 volt load, whether it's your 240 volt mini split, your oven, your dryer. If you are basically, like a lot of people, trying to build a bigger off-grid system, the 240 volt loads, they're not even touching the transformer. So the transformer, the 5 kW number on the transformer doesn't even touch 240 volt loads. Now, what does it mean to 120 volt loads? Well, obviously, anybody who's going off-grid, building an off-grid system, best practice is to have a load sheet as to their actual loads that you're going to use. So you line out, okay, what off-grid 120 volts are you going to be having? And I think that a lot of scenarios I've seen in terms of people saying, oh, you'll need more transformers, you have problems, a lot of them are based on some ridiculous 120 volt loads that off-gridders don't put into their daily lifestyle, like a whole lot of 120 volt heaters. I don't know anybody who really wants to buy the battery bank for that, or the solar panels for that. But yeah, absolutely, if you wanted to stack 10 120 volt heaters, you're going to need more transformers. But if you add up all your 120 volt loads, and let's just say that we can agree that we have even 5 kilowatts of 120 volt loads, and I assume some people could have more, but it's really rare. But even 5 kilowatts of 120, how does that get split up? Well, if you put 5 kilowatts all on line 1, and you didn't do any line balance analysis, because even 5 kilowatts is a lot of 120 for an off-gridder. If you do that, then you'll be 5 kilowatts imbalanced, and that's technically a little more than one transformer can handle. You should get a second transformer. But if you got 5 kilowatts, the thing about Autotransformers is that if we have, let's just write this out in terms of line 1 and line 2. If line 1 has 2 kilowatts and at 120, and line 2 has 3 kilowatts at 120, then what you really are loading, so this equals 0 watts for the 240, and then if we were to take these two pieces of information on line 1 and line 2, that equals the 1 kilowatt differential is what we'll load on the transformer. The 2 kilowatts on line 1 and the 2 kilowatts on line 2 will combine together to make a 4 kilowatt 240. The transformer has nothing to do with the actual 4 kilowatts either. So that's not even material mathematically. It's the imbalance. Now yes, if you did not balance this, if you did, if this here was, you could do 4 and you could do 1, which again, 4 kilowatts of 120 volt loads is kind of colossal for a continuous amount of time. And we're not talking motor surge here. We're talking something like resistive, some kind of steady load that could actually, I think I've seen some people that were running the transformers up to 240 degrees or something. So continuous heavy 120 volt loads, like heaters. And 4 versus 1, that means your differential is 3 instead of 1. Again, you look at your load sheet, and if you have 5 kilowatts of 120 volt loads and you intend to balance them, you can get away with a 5 kilowatt transformer. You intend to balance them with some degree of reason. Again, that 4 to 1 is still within a range on a 3 kilowatt imbalanced transformer. If you have a 5 kilowatt transformer, and if you have less than 5 kilowatts of load, then that transformer is fine. If you're going to have more than 5 kilowatts of 120s, which, by the way, I'd like to know why, but if you're going to have more than 5 kilowatts of 120s, then a second transformer would be necessary. And so basically, just understanding sort of the value behind the 5000ES and the 240 volt inverter modules is that if you're an off-gridder and you buy this, a 5 kilowatt and a transformer, and it's more than enough to cover your 120 volt loads, and you say, you know what, we'd like to put a dryer in. Well, guess what? You only have to buy a 5 kW. You don't have to buy anything else. We don't make you buy something you don't need, because that is $900. Now, if you run on any other inverter brand system, you're going to be on the hook for a lot more. $500, $600, $700 more for the same inverter capacity. And they don't even have the high voltage charge controllers, which you lose a lot of money buying fancy combiner boxes that aren't required thanks to the way the NEC is written. You can, when you go up to that high of a voltage, 450 volts on the MPPT, then you don't need to have these big combiner boxes because you're wiring up for low voltage. You don't need to buy all that extra wire. It costs you, the way I used to look at it with combiners was that a combiner box, really, the total cost is around $350 to $550 when you factored in all factors. So that's another loss on top of the inverter loss. So it just made it where, things were significantly more expensive. And if you're adding a dryer to this load, you're not going to load that transformer 1 watt more by adding a dryer. If you say, you know what, we want a dryer and we want 3 1-ton 240 volt mini splits, like the high efficiency ones we carry here at Signature Solar. Who cares about the transformer then? That's a 240 volt load. Who cares about the transformer if you got a whole house air conditioner? If you're trying to take, a facility off the grid, the vast majority of the loads are 240. You have to control your 120s and buy the right amount of transformers for those. And so, unless if you have an inordinate amount of 120s that you intend to be running, resistive 120 loads, which typically they eat a lot of lunch kilowatt hour wise. It's really hard to to build a system on that. But if it's what you're bent on having, you're welcome to buy more transformers from us. But the flexibility of this system is you get the 450 volt charge controller. And you don't have to pay for things you don't need. You just buy a 240 volt inverter board, and that's all you've got to have. We can kind of illustrate this here. I'm going to kick this on and just walk through where the amperage is going. So I've got a 6 battery bank here. And this is one of our originally US model inverters. We don't touch, they come here in boxes and we ship them out in boxes. We bought the right units. I've got this thing up and running. And I've got this handy little cart here. I've got a dryer. I've got two 120 volt loads. We're going to have this just to illustrate sort of the return current coming back from the neutral, because this is the business line of the transformer. And as you can see, I've got my transformer hooked in with the dryer plug here. And it's just a handy little thing we use to test stuff out. So I've got power coming back from the inverter, and it's getting landed. We've got what we need right now to run this dryer. So we're going to go ahead and start this thing. I've got, as you can see, 23 amps. Actually overrunning the inverter a little bit. 23 amps on line 1. 23.6 amps on line 2. And the amperage on neutral is 3 amps. That's just basically the amps needed to run the fans and the motor inside of the thing. But the vast majority of the power here is 240 volt. So just sort of showing that, I'm going to turn this off. That's a 240 volt load. If it was the air conditioner, it'd be straight out 240. We wouldn't even need the 120. But let's go through another scenario here. I've got two 1500 watt heaters, 120 volt. This is one circuit, this is another. I've got two circuits here. So I've got these all turned on to. So let's go ahead and turn on one of these heaters. And what we're going to see is I've got 3 amps on line 1. Second here, it's ramping up. I got 7 amps on line 1, on line 2, and I'm up to 7 amps. So that's 14 amps, okay? So 14 amps in, and my return current here is 14 amps. Now, what happens when I turn the other heater on? What do you know? It goes down. The transformer is working less right now. We added another 14 and 2 identical heaters. I am pulling 0 watts from the transformer, running 2 heaters because I balanced them. So that's kind of a good illustration as to, you know, how all this works. It's not even pulling the total load of these. It's the probability of how far imbalanced. If you have 5 total kilowatts of 120s, which again is pushing it, and you say, well, what's the probability of me imbalancing those? I mean, if you're living off grid, you're living intentionally. You've got an idea as to when you're pulling these kind of heavy loads, and you've got a plan based around that. So at the end of the day, yes, I could go and if I wanted to make a scene, I could go grab 10 of these heaters and plug them all on line 1 and run this transformer up to 240 degrees, but that's just not practical. So hopefully that just illustrates the key points that we have here. So we're going to go kind of show you guys what we have a larger main distribution panel we'll take this video to and kind of show you what happens when something goes wrong, because I think everybody's tripping this out assuming that they took that lineup of 10 heaters and then turned it off, and yes, you have full potential. But if you were semi-balanced before and grounded, then you're not going to hit things with 240 volts. But the reality is that if you really want to have double protection, other than making sure you size your transformer right and you balance your loads, if you want to have double protection on top of that, there's a way to do that. And so we're going to show you guys that in just a second. Okay, so I've got a bench here, and from an off-grid perspective, this is a dystopian horror film. I mean, we've got like 5 electric heaters. I mean, I threw mine away 10 years ago. But yeah, if you were an off-gridder that wanted to have 5 electric 120-volt heaters, here's how you could protect that. You would put all of your inverters together and transformers on a separate breaker panel. Okay, so that is basically your combiner box for all those inverters you're picking up, one transformer or 2 transformers. We're going to show you one transformer here. I've got one inverter running off this battery bank, and we have the transformer tied into this breaker panel. It's a little messy, actually really messy, but I've got the transformer and inverter in on this breaker panel. Now I could have 5 inverters on this breaker panel, and I have 1 transformer if I want, or 2 transformers, whatever's appropriate, okay? And what I've got here is I'm feeding this breaker, but the thing is that I come out of this breaker panel into my input breaker on this panel, which, because, I don't know, somehow we went cheap, we should have had a main breaker, but you wouldn't use a main breaker because you would land it on a breaker that is correspondent to the amperage rating of your number of transformers. So I got one of our solar edges from last year. That's a 25 amp breaker on that transformer. It's what it recommends. So I've landed that on a 25 amp breaker. If I'm using the new Growatt ones, that's a 20 amp breaker. Now, if my main combined breaker panel had 2 transformers, a Growatt and a solar edge, then I'd be looking for 45 amps. I'd probably just say we can get away at 50. Because what you're going to find out here is that this is going to provide the level of overcurrent protection that will protect your 120 volt devices. Again, you can pull your 240s off of the 240 volt combiner panel, and your 120s, if you go this route, it's pretty straightforward. I've got a bunch of these heaters running right now. If I look at amperage, I'm pulling 28 amps on one leg, 11 amps on the other. So this is showing the product of downstream of the transformer. So this is where you actually achieve the ability to control the situation. Now 28 amps eventually is going to trip this 25, but it's going to take a while and I don't have time for that. So let's go ahead and turn on another heater because we're that psycho, and we're at 35 amps. 37 amps, 38 amps. And it can't be too long, guys. This will trip. Oh shoot, this inverter doesn't like that. Here. We're at 31 amps. So it's getting above one inverter's capacity. 30 amps. Hey, come on. What do I have on the other line I can pull off to sort of drive this thing? Let's see. I think, yeah, perfect. So this is total imbalance. I'm pulling 42 amps, 91. Okay, so I'm pulling 42 amps on the thing. Totally imbalanced. What's going to happen? As you can see, the transformers, there you go. Now, the cool thing is, when this tripped, it tripped the 120 volt hot lines, line 1 and line 2. So the neutral's still here, but the hot lines got tripped by overcurrent protection. So if you absolutely don't trust your mathematics on calculating transformers, and you've got a lot of heavy 120 volt loads, and you can't make sure that you've got it right, you could absolutely just feed out of that AC combiner panel you're going to need anyway to parallel your inverters. Feed your 120 volt panel with the corresponding right size breaker, and you've got overcurrent protection. But that still leaves you in a position to where if you want to add, as an off-gridder, if you want to add serious 240 volt loads, that's a $900 purchase. And if you buy the right unit, you know, and frankly, you know, this is not anti-competitive of us. We have, you know, I've really failed to market this one, the fact that we were doing the right thing here, just because of, I don't like negative marketing, but, you know, if people want to talk about the safety from folks that are bringing in the wrong units and not doing their homework, I mean, yeah, that's fine. It's got the same brand and model as mine, so I've got to got to explain it to everybody. But there's no reason why any of this has to be unsafe. It's actually an incredibly exciting system, and I think it really has been leading edge the last couple of years. And we have so many customers that are buying systems that have done them and are doing more of them. I mean, I think that most of the voices we're hearing here are, frankly, coming from people that don't even own one, and that's really unfortunate because we've got so many happy people who have systems like this, and for this reason are really thrilled with it. Again, I think like we showed before, we actually ask for, buy, and receive the U.S. units. So if you like the concept of this system, and we think that, the scary part of if you do try it is that you probably will like it, like so many of our customers. If you do, go ahead and, we don't want to plug ourselves, but it turns out we're about the only ones that are buying it right now. So I hope at least that we get some more of these drop shippers and other folks that don't really have a relationship with the manufacturer to start buying the right unit. And this can be a good idea going forward for people who have these priorities. If you're a practical person, you've got your 120 volt loads tabled out, and you just want to add those bigger accoutrements that most people tell off-gridders no you can't. This is the most cost-effective way to do that, and absolutely can be done in a safe manner. So anyway, that's our walkthrough of the concept of the 5000ES and what we really think that people should know about it. I think we try to walk through this for people who call our sales department, our tech department, but it seems to be there's just so much other marketing out there and confusion in the ether that we're just dropping this out to the general discussion. So hopefully this helps. Thanks.